Hi, my name is Seth Price, and I'm the project manager for Aurora Industries. This week, we're going to be working with a different type of robot. In the past, we've used the bumper bot and the X-bot, but this week we're going to be using the claw bot. This will help us utilize the claw on the robot to move certain materials around our Martian expanse.
Hello, my name is Jake Hamilton and I'm the media designer at Aurora Industries. Our end goal for this project is to be able to fully automate the gathering, analyzing, and organizing of minerals gained previously from the drone robot. The drone comes down, gets the materials and minerals from the mine, drops them off in boxes, which will be sorted by the clawbot.
Hello, my name is Justin Belarjan. I am working with Aurora Industries, and I am the lead coder and design team member. And today I will be going over the code that was done for this assignment. So this first part is just the setup that we get that is already there for all of our robots and assignments, and it basically just assigns all of the motors and sensors, things like that. I've also defined two variables, being our power and our distance, that is used in some of the drivetrain functions. And this is our first, so this is just our basic forwards and backwards movements. And yeah, so I built the drivetrain so that on our next project, which will also use the clawbot, we can reuse some of these assets, right? So forwards and backwards, they use the power to automatically set the velocity so it can change between iterations, and it also shows the distance, which is interpreted as degrees. This is our left and right, which is similar to the forward and backwards, except the values are altered slightly, so that way if you're turning left you want the right wheel to actually go faster and farther than the left wheel in order to correctly turn. And we actually used, if I recall, only the left one in this project, but in future projects we already have the drivetrain developed so that we can use it in the future. And this is all of our claw movements. So this is very, very basic movements. It's just opening and closing of the actual claw. One thing that I found out is that in order to lock something in place, you need to have the clawbot stop and initiate a break. That way it won't release when you actually want it to continue holding. Right? And this is our actual calling of all of our functions in the drivetrain, right? So we go backwards, we wait, and we initiate all of these to hopefully take our subject and move it from one place to another.
I'm Carlton, and I'm the information analyst for Aurora Industries, and our robot for this week is the clawbot robot. This robot will be using 4 2-wire motor 393s or 393 type motors by VEX, which are they provide 60% more power, like more output than the standard VEX motor, which will allow for more powerful mechanisms and drive bases, meaning that this robot can go faster, more torque, more power, all better for our purposes on Mars, especially since it has to pick things up and put them down as it has a claw. So that means that this robot has different types of gears. Like the motors have different gears, so it has strong internal gears that will allow for it to be configured into different versions. So the standard version is the standard speed, just 6% more power. But this version also can go into a high speed configuration where you get more speed output at the expense, obviously, of less torque. But these motors will be very useful to our clawbot on Mars, because picking things up, putting them down, very heavy. Small gravity on Mars though, but it's still a task that needs to be accounted for, which means we need stronger motors, which is the motor 393 provides.
So for this week's bot, we are using precision on code rather than using a sensor in order to identify an object in front of our clawbot. For the clawbot, it will be using precision based off a GPS located physical object that is blocking our mission, and it will precisely pick it up, and it will use its ranges of motion, which is rotating, moving back and forward and left and right, to then move the object out of the way to make room for the Clawbot to come in. This precision and for the objects that is going to be identified and moved by our Clawbot will be identified by our drone after using cameras to actively map our area of investigation that we're doing on the Mars polar ice caps.
Alright, so right above me is the robot running, and with our code over here, we have hard coded the robot with the layout of the warehouse so that all of the boxes are organized foot by foot by foot. We'll have the minerals stacked next to each other in a geometric sequence, and it'll be just super organized and will increase our efficiency drastically.
Hello, my name is Willem. I'm the Safety and Security Officer for Aurora Industries. Today we'll be talking about some of the safety concerns and how we're going to tackle them for our Clawbot. The first of which being the wheels themselves on the Clawbot, which are made of a special rubberized material that allows it to grip to the floors on our warehouse. The second concern is the claw itself. Now the claw is built with rubber tips on each end of the little spikes so that it can grasp boxes in our warehouse successfully without them falling on us.
So as Aurora Industries, we had a lot of problems with this project. There was attendance, there was recording, there was coding, and there was the actual simulation software. So Justin did his wonders. He figured out the code. There was an issue where it wasn't turning 90 degrees, so we couldn't have it navigate, but he fixed that. And there was an issue where it couldn't pick up the box and cube game object in the simulation. He fixed that by running it up with a capsule instead of a box. And we had tons of issues with attendance because Cole and Lucas, they weren't here for 2 days, so that was just really tough on our team, but we prevailed by having them record where they were and submit it, and we got it done. Overall, this was a stressful project, but glad we're on bake, and happy Thanksgiving.